I mentioned that one of the benefits of the root zone is that it attracts a lot of life, if you want. It does that in several ways, one of which is that the surface area of a root zone is surprisingly large. We measure about 12,000 square meter of root surface area in each cubic meter of reactor space that the roots occupy. That's a tremendously large number. And as you can, everything happens in microscopic scale, of course, but it's still a lot of organisms that can attach themselves. Another beneficial aspect of the root zone is that plants pump oxygen through their roots, and therefore the biofilm that develops on the outside of this is a hair root, a microscopic picture of a hair root. So the biofilm that develops on the perimeter of these roots will get some of the oxygen supply from the plants. That means you have to pump a little bit less in, so you do have some savings right there. Plants also exude enzymes into the environment, and they actually develop a symbiotic relationship with the biofilm that develops on the roots. That creates a healthier community that is attached in that zone. In the industry, generally the biofilm that develops in treatment plants, the health of the biofilm and the nature of it, the structure, how it behaves, is directly related to operational problems or advantages. And what we find is that the biofilm that develops in the root zone is an exceptionally healthy biofilm with very favorable structure that translates to operational advantages. What we can see on this slide is actually a photograph of the biofilm that develops on the left-hand side in a typical root zone. And I would point out to the loose structure, first of all the mass and the loose structure of the biofilm. That's important because once you attract all these creatures, it's very important that they get to air, that they don't get suffocated, right? And they also get good access to the food in the water. So material exchange, both from the gas to the liquid phase, as well as from liquid to the solid phase, to the biofilm, is very important. So therefore, the structure, how these creatures attach themselves and how they connect to each other, is very important, because if it allows for the movement of water freely, that will mean an efficient exchange of material. What you see on the right-hand side is what is being used typically in the industry, and this point on the middle on the top and the one on the left are actually in the same scale. So in the industry you can find attempts to put in some sort of a carrier media that will also attract the growth of a biomass. And these are components that would be called moving bed bioreactors. So you throw in a lot of these little plastic discs, and after a while the bacteria will grow on the inside of the disc. The point here, the illustration here, is the difference in the mass as well as the structure in this biofilm. On this slide, you see, on the left-hand side, you see the artificial root structure, the biomodule that I talked about. And here, this construction worker gives you a good sense of scale. But on the right-hand side, to some of you, it may be a little bit disgusting as a picture. But in fact, to technology expert, this is really like a wow effect. Because you have a lot of, as I said, you know, instead of a couple of millimeters thick biofilm, here you have centimeters, 2-3 centimeters deep biofilm. And the biofilm is very loose. It's really actually a spatial matrix. That's important because of the material transfer aspects that I mentioned. We talked about the number of species, which was more than 3,000 as opposed to the the few hundred. What we also find that we can, with this method, with the combination of the roots and the artificial roots, the natural and the artificial roots, we can keep somewhere between 12 to 18 kilograms of bugs or creatures in the same reactor space. That's quadrupling both the diversity as well as the mass. Now you can imagine that a certain amount of food will be eaten by a certain amount of creatures, just like we would do here if we had a nice lunch after this. The more density you can have, the less space you will need, which translates then to much smaller footprint and capital expenditures as you build these treatment plants.